Hi there, this is Ms. Page, and this is our second lesson in our Unit 4 on graphing quadratic functions. And this lesson is going to focus on graphing quadratic functions that are in what we refer to as standard form. Standard form is when everything is all multiplied out and the terms are in descending order of x. So we start with x squared, and then if there's an x term, it's next, and a constant term would be at the end. So this one's a little different from vertex form in that we cannot just look at standard form and know what the coordinates of the vertex are. We have to actually do some math in order to calculate the coordinates of the vertex. And that is what this is talking about. So to find h, we are going to need to do this math right here. We're going to have to take our b value, which is shown here in our standard form, the coefficient of x, and this negative here tells us that we are going to have to take the opposite of that b value, or multiply it by -1. And then we are going to put that over 2 times the a value, and the a value is what we find in front of the x squared this time. All right, it's the same a value as in vertex form, quite honestly, but it's just in a different position, and it was part of how we figure out the h value for the vertex. So we do that math first, and that gives us the x coordinate of the vertex, -1 times b divided by 2 times a. So then once we have x, in order to find the k value, what we are going to have to do is plug our h into our function and do the math. And that is what this is saying right here, f of our h value. So we are finding f of h, and that is then the y coordinate of the vertex. Another thing that we're going to be doing once we create a graph is identifying the zeros if we can exactly. So remember, those are the x values of the points on the x-axis. So the zeros would be -3 and +1, not the ordered pairs. And we'll also look at some graphs where our zeros are between two integers. So in those cases, we will say the interval of integers that are zeros between. So here we know the 0 is between the whole numbers of 2 and 3. So we have an interval of 2, 3. We know our 0 is in that interval. And here we can see our 0 is between 6 and 7. So we would make the statement that the 0 is in the interval from 6 to 7. All right. So here's the procedure that I'm going to teach you for graphing from standard form. We're going to use what I was discussing on the first slide about how we calculate the coordinates of the vertex. So we'll figure out our h and k values. That -1 times b divided by 2a is our h, and then plugging that in to get our y value. And so then we would do our f of this value, and that would be our vertex. We'll graph that vertex. Then we're going to do something a little different. We're still going to use those key points that we have learned how to use from our f of x equals x squared and transformations. We're still going to use transformations, but instead of starting at the original position, we are going to learn how to adjust it so that we can just do the stretches, compressions, and reflections. We'll actually kind of all automatically have the translations already set up. That's what this is talking about. So we're going to look at the horizontal line that goes through the vertex. So if I've got this parabola like this, I'm talking about this line right here. That's going to be my line of reference, not the x-axis. And then we'll do our reflections, and if we have a stretch or compression, we'll do that too, and that will give us our other points relative to the dashed line, and we'll be able to draw in our smooth curve parabola, and then we'll erase any dashed line. And some of you might, after a while, not even need to do the dashed line. You'll be able to see it in your head. All right, let's go. So, instructions. We are to part A, graph using transformations. So it's going to start off a little differently than we've already done, but it'll end up the same. And then once we have a graph, part C, after we have a graph, we'll state the zeros or the interval in which a zero is located. We'll need the graph before we can do that. Part B, we can actually do either first or second, or I guess we could even do it third. Because we're going to calculate our vertex, remember, before we can actually start with our graph. And then we should know if it's a maximum or minimum based on whether there's an x-axis reflection or not. All right, so here we go. First thing we're going to do is find our vertex. So what we need to know are the values of a and b in our standard form. So the coefficient of x squared, which is a 1 here, that's our a. And the coefficient of x, which we have to take as a -6, that's our b value. Our vertex, we're going to do -1 times b divided by 2 times a. That's our h value, the x coordinate of our vertex. So we're going to have -1 times -6 divided by 2 times 1. That would be +6 divided by 2, which is 3. So now we know the x coordinate is 3. To find the k value, the y value, we are going to figure out, well, what is f of 3? So we're going to plug 3 into our x's, and that's going to give us 3 squared minus 6 times 3 plus 5. So exponents first, that's a 9, then multiplication, minus 18 plus 5, and then left to right for your addition subtraction, this would be like a plus -18, so that would be a -9 plus 5, and that would be a -4. So that is our k, our y coordinate. So there's our vertex. And so that actually has to be clearly stated. Remember, this is actually part of the Part B instructions. The other part of Part B is to state whether this vertex should be a maximum or a minimum, and we can tell that from the a value. So our a value is +1. If a is equal to +1, we know there's no x-axis reflection. That means that our parabola opens up, putting our vertex at the bottom, making it what we call a minimum point. So we can go ahead, and Part B is now done. So the absolute value of a is the absolute value of 1, which is 1. And 1 is equal to 1. It's not greater than 1, so there's no stretch. It's not less than 1, so there's no compression. So when we get 1 equals 1, we know there's no stretch, no compression. So now we'd be ready to start Part A, the graphing. So here I'm going to have to draw my axes, and I have to consider where my vertex is, because I should draw my axes so that I can fit as many points as possible of my 7 key points of my parabolas onto my graph. So 3, -4 would be like a translation to the right 3 and down 4. So if I'm translating right 3, I'm going to move my y-axis to the left a little bit. And if I'm going down 4, then I just need to make sure, and I'm opening up because it's a minimum, I just need to make sure I can get down to -4. So I'm going to move my x-axis down. Now I encourage you to put at least a few numbers, like the even numbers or the odd ones, because that helps keep you from graphing points in the wrong spots. And then I'm going to graph my vertex. So my vertex again is 3, -4. Let me put some negative numbers on here. Okay. So 3, -4 would be right here. Okay, here we go. So what are those key points of our parabolas again? This is super important to remember. Remember that we have our actually -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. There's no stretch, no compression. And so what happens, this is the neat thing, I'm going to use this line right here that goes through my vertex as my reference line for all my points. So the nice thing is that there's symmetry around the vertex. So to the right one, I'm going to go up 1 because there's no stretch, no compression, and no reflection. So I'm still using 1, but it's relative to, so this is 1 unit. Then left 1, up 1, because they have a sister point, remember, that partner over there. Then we have 2 4s. So we go from our vertex, right 2, up 4. That's our 4. And then we have the partner or sister point over there. And then we go right 3 and up 9. So that's 4, 5, 6, 7, 8, 9. That would put it right there. That's our 9. And then on the other side, left 3, up 9, right across from it. So that then gives us 7 key points. And now I would get rid of all of my little dash line work stuff that's not really part of my graph, and I'm going to draw in my parabola, a nice rounded U-shaped curve, and put my arrows on the ends like so. All right, let's take a look at another one. So here we're going to graph, oops, hang on, I forgot part C, shame on me. Part C. That's the thing, always good to reread the instructions and make sure we've done all parts. Part C, we haven't done that yet. State the zeros or the interval in which the zero is locating. This time we can actually see our zeros because they are these points here and here. So for part C, I'm going to say the zeros are +1 and +5. So 1 and 5. There's my part C. Now we're all done. Okay. Now let's go back to that other one. Here's our second example. Okay. So again, I need to start actually with my part B because I need to figure out and calculate what my vertex is. So this one we have to realize that the -2 would be our A, and the 8 would be our B. The C is 0, because this would be like +0, and that's the C value. So we don't need C anyway, so it's not that big a deal, but you should understand that, well, yeah, the C is a 0. So now for our vertex, do you remember how to calculate the vertex? How do we get the x coordinate of our vertex? We take -1 times B divided by 2 times A. So that's going to be -1 times 8 divided by 2 times -2. That's going to be -8 divided by -2, which would be a +2 in this case. So our vertex has a +2x coordinate. And then our y coordinate, or k, we're going to find c of 2 times 2 squared plus 8 times 2. So no calculators here. This is pretty basic math. We just follow order of operations. We do our exponents first. 2 squared is 4. Then we do our multiplication. -2 times 4 is -8, and 8 times 2 is 16, so we get -8 plus 16, which would be a +8. So our y coordinate of our vertex is 8. Now, remember for part B, we're also supposed to state whether that's a maximum or a minimum, and that has to do with our A value. So this time our A is -2. So because it is negative, there is an x-axis reflection. And that means our parabola is going to open down, putting the vertex at the top, and we call it that then a maximum, because it's the highest or greatest point. So this now finishes up part B. So now I can move on to my graph, and I want to create my axes. So I know my parabola is opening down, and I know my vertex is at 2, 8. So I don't need to go any higher than a y value of 8, but I need to make sure I can get that on there. So 2, 4, 6, 8. So I'm going to draw my x-axis here, and the x is 2. That's actually a shift to the right 2. So again, I'm going to move my y-axis a little bit to the left, but it's not that big a deal. Again, I encourage you to put at least some numbers, like evens or odds, on your axes to help with accurately graphing your points. All right, so now I'm going to graph my vertex, which is at 2, 8. And a strategy I kind of like to use sometimes is use my V as an indicator, so I'm going to put my V above it, and then that's kind of like my boundary, my barricade. I can't go up, I have to go down, because the V's in my way, I can't go up. And that way I don't make a mistake. Because I see people who know it's supposed to open down, they know the vertex is supposed to be a maximum, yet when they graph it, their vertex is the minimum. So be careful about that. So now I have to figure out what else A tells me. So I know I have this x-axis reflection making the parabola open down, but the absolute value of A is 2, and 2 is larger than 1. So that actually tells me then I also have a vertical stretch, and the factor of my stretch is 2. So I'm now going to use this line that goes through my vertex as my reference line for my stretches. So my y values are all going to stretch. My y values are 0, that's my vertex, which doesn't really matter, it's going to stay at 0, 1, 4, and 9. Each one of these gets multiplied by our factor of stretch, which is 2. And that's going to give us new vertical distances of 2 and 8 and 18. That 18 is probably not going to fit, but we'll check. And so that means that I'm going to go from my vertex, I'm going to go right 1, and then I'm going to go down 2. So now my stretch distance is 2. That's my factor, actually, not that one. So my stretch. So now I've got the 2 there for my vertical distance. And then on the left side, left 1, down 2. So then my 4, I'm going to go right 2, but instead of going down 4, the stretch makes it, I have to go down 8. So 2 all the way down 8 would put me here. This vertical distance is now 8, and I have that reflection going on. And then on the other side, would give me the sister point right there. And then the 3, 9, I'd go right 3 and down 18, but I can actually only go down, looks like 15, so it won't quite fit on that. So I can't graph this one, but that's okay. And I am going to graph now my parabola. Oops, I don't like that. It should not, remember, look like it's going to go straight down. I need to get it into that space. And then I'm going to get rid of my little dash line that I used for reference, which you don't even have to graph if you don't want to. Then I can't forget part C, like I did the last time. So state the zeros or the interval in which. This time again, we can actually see what the zeros are. They are at 4 and at 0. So our part C would be a statement that the zeros are 0 and 4. All right, moving on. So here's a practice problem. I want you to do this problem on your guided notes handout or your binder paper. All right, let's take a look at it. So hopefully you came up with a vertex here of 3, 1. The math here is shown for X and Y if you need it. And this time it's a maximum because your A value is -1 here. So be negative, that means that we have a reflection across the x-axis, putting our vertex at the top. And then the absolute value of 1 is 1, so there's no stretch, no compression. So all we have is the reflection. So we graph 3, 1, here's our vertex. And then our 1, 4, and 9 all stay the same. This is 1, this is 4, and sadly this graph did not show the 9, but you should have shown the 9 as that next pair of points. All right, and then zeros, we can see the zeros are the nice whole numbers of 2 and 4. All right, another example for us to do together here. So this one, it's got some differences to it. As you can see, we have an A value of 1/2. So we want to make sure everybody is comfortable with the math there without a calculator. So we're going to start with our vertex. So the x coordinate of our vertex, remember we calculate -1 times b divided by 2 times a. So our a value is the 1/2 and our b value is this +4. C is 5, but that doesn't matter for this. All right, so that means we're going to have negative 1 times 4 divided by 2 times a half. And negative 1 times 4 is negative 4. 2 times a half, remember, you can look at it as 2 over 1, and then that would be 2 over 2, which equals 1. Or you can cross cancel. Gets 1 over 1, which is 1. Or you can just look at it conceptually. What is half of 2? Half of 2 is like 2 divided by 2, which is 1. So then anything divided by 1 is itself. So that gives us a negative 4 for the x-coordinate of the vertex. Then we find y exactly the same way as we have been. So we're going to do 1/2 times negative 4 squared plus 4 times negative 4 plus 5. So following order of operations, we do our exponents first. Remember that when you square a negative number, that means negative times negative, which is positive. So this is a positive 16 times a half. So that would be 16 divided by 2, which is 8. 4 times negative 4 would be a negative 16. And then we go left to right, so 8 plus negative 16 would be negative 8. Negative 8 plus 5 would be negative 3. So our y-coordinate of our vertex is negative 3. A here is positive, so there's no reflection, so our parabola is going to stay opening up, putting the vertex at the bottom. So that means we say it's a minimum. All right, so there's our part B. Now we move on to our graph. So I need to make some decisions here about my axes, and I also want to figure out with my A value, I know there's no reflection, but do I have a stretch or compression? This time our A value is, I'm going to put it down here for space, 1/2, and the absolute value of that is 1/2 still, and that's smaller than 1. So this is our factor, and it's smaller than 1. That means we have a vertical compression with a factor of 1/2. So things are going to get really smaller. So our vertical distances from our vertex of 1, 4, and 9 are all going to be multiplied by 1/2. So this is going to be 1/2. 1/2 of 4 is 2. 1/2 of 9 is 9/2, which is equal to 4.5. All right, so that means that pretty much I just kind of have to be aware of where my vertex is. So my vertex is at negative 4, negative 3, which is left and down. So I'm going to move my y-axis to the right a little bit to give me some space over there on the left. And I just have to make sure my x-axis is going to get me to negative 3 here. Again, I recommend a few numbers to help with making sure all the points are graphed correctly. Okay, I'm having a little issue here with getting things to look like numbers. There we go. All right, so my vertex is at negative 4, negative 3, and it's opening up, so I'm going to put it down there. I need to go up, not down. And now, remember I already did my math here for my new vertical distances, and those are relative again to the line now that goes through my vertex. So from here, I'm going to go right 1. This is my right movement. 1, actually no it's not. I'm taking the 1 to the x's are the movements for the right. So the x's are 1, 2, and 3. So never mind about that. Try to get that out of there. So I go right 1. These are my y distances, my vertical distances, up 1/2. And then on the left. And then I go right 2, up 2 instead of 4 on both sides. And I go right 3 and up 4.5. 2, 3, 4.5 on both sides. So here's our parabola. And I'm going to get rid of my little dash line here. So there's my graph, and now part C. So this time we're looking at zeros that are not integers. They're between integers. So here's where we're going to use that interval notation. It says state the interval in which a zero is located. If we can't say exactly what they are, then we say what interval they are in. So these are fractions or decimals of some kind. So for our part C, let me get rid of this, give me some space. So for part C, the zeros, I don't say the zeros are, I say they are in the intervals. So my first interval, remember they're least to greatest intervals, so it starts at -7 to -6. That's that zero. So from -7 to -6. And the other zero is in this interval over here from -2 to -1. And that would finish up all three parts. All right. Here's a practice problem for you to try, again on your guided notes or your binder paper. Okay, let's take a look at what we should have. So hopefully you calculated your vertex correctly. The math is shown over here. So your x coordinate is +2 and your y coordinate is -1. So, and this time it is a minimum because A is positive, so there's no x-axis reflection. There is, however, because A is 2 and 2 is greater than 1, there is a vertical stretch by that factor of 2. That means the 1, the 4, and the 9 all get multiplied by our factor of 2, giving us 2, 8, and 18. So notice this distance is now 2. This distance is now 8, and the 18 doesn't fit on the graph. And it's relative to the line that goes through our vertex, like that right there. All right, that finishes up this lesson. I hope you have a wonderful day.